Hey everyone, here we are, another day of code. We are on day 7 of the Advent of Code. Advent of Code is a 25-day code challenge. It happens every year in December, where people get these little programming challenges, and they try to save Christmas, or in this case, we're going on vacation. I usually do them for a few days, and then I fall off. I am now on day 7. This is the longest I've ever done them before in my life, so that shows that the plan is working. The plan is not simple. It's well, I guess it's actually simple, but we're not gonna steal other trademark work here, right? We're better than that. But anyway, the plan was I do this on stream so that people can watch and motivate me to continue on, or at least I feel the obligation of, oh God, I have a stream, I gotta do this. I can't get distracted by work or other obligations in life. And so far we have been keeping on. Uh, I took a little peek at today's earlier, and it looks like it's gonna be not hard but annoying. So we'll see what comes of this, right? We're gonna get through this together. Just shrink this down. I don't know why this isn't Windows not behaving quite right. Let's run this over here. Oh, I was pressing Alt instead of... Okay. So these should be tiles. Yeah, these are now tiles. Okay, we're good to go. So let's see what we have for today. If you haven't been following so far we're going on vacation. We're not saving Christmas like how we usually do. We're going on vacation, and so far, to get out of the North Pole, we didn't have a passport, which was a bit of a disaster, because instead we had a North Pole ID card thing that has everything a passport needs except for the country. And so we hacked things to get the system to ignore that. Then we couldn't find our boarding pass, so we did more code to figure out where. And then there was the questionnaire, the customs questionnaire, and we did well by everyone, right? We helped out some people that were having troubles with it, and we I don't know really what we accomplished with that, but we tried something, all right. And we got more stars. That's the important part. We got stars. Look at these, 12 stars. So pretty. So let's move on to day 7. Let's stop filibustering and just have a nice chill stream, just talking through whatever happens next. Andy Haversacks. You land at the regional airport in time for your next flight. Oh, we have a connecting flight. I hate a connecting flight. That's very, very sad that we have to do that. I guess there aren't that many flights coming out of the North Pole, though, so we do what we can. In fact, it looks like you'll even have time to grab some food. All flights are currently delayed due to issues with luggage processing. Is that a link to something? We never click on these links anyway. Due to recent aviation regulations, many rules, your puzzle input, are being enforced about bags and their contents. Bags must be color-coded and must contain specific quantities of other color-coded bags. Okay, that's very odd. Apparently, nobody responsible for these regulations considered how long it would take to enforce. For example, considering the following rules. Light red bags contain one bright white bag. I don't know if the comma is and or, but comma, 2 muted yellow bags. And we have a variety of, it seems to be a descriptor, a color, and then bags contain number, descriptor, I guess adjective would be the right word. Adjective, color, bag. Would it be an adverb? Because I think an adjective, something that describes another adjective becomes an adverb, right? I don't know. I'm not a grammarian here. We're just working through this, guys. Let's calm down. So there can be multiple of these comma separated things, or there could be only one. I don't see any cases where there are 3. Faded blue bags contain no other bags, so that's another like magical statement, it appears. These rules specify the required contents for 9 bag types. In this example, every faded blue bag is empty. Every vibrant plum bag contains 11 bags. Vibrant. Oh, so it's an and. So it has to contain the other thing. Okay. That's reasonable, I suppose. You have a shiny gold bag. We are incredibly fancy, apparently. with our shiny gold bag, tearing up the town. If you wanted to carry it in at least one other bag, how many different bag colors would be valid for the outermost bag? In other words, how many colors can eventually contain at least one shiny gold bag? So we can have more than one shiny gold. Okay. In the above rules, the following options would be available to you. A bright yellow bag, which can hold your shiny gold. Let's actually just. Oh, okay. So bright yellow bag can hold it directly. This parsing is going to be annoying, so I think we might end up borrowing the input here as kind of like a test case for our V1 of this. A muted yellow bag, which can hold your shiny gold bag directly, plus some other bags. So muted yellow, shiny gold. Yep, that checks out. That checks out. A light red bag, which can hold a bright white bag, and muted yellow bags. Either which could then hold your shiny gold bag. Okay, this all makes sense to me. This all seems reasonable. So, in this example, the number of bag colors can eventually contain at least one shiny gold bag, which is 4. Okay, how many bag colors can eventually contain at least one shiny gold bag? Okay, so the annoying part of this is going to be the parsing, obviously, right? This is just going to be like a kind of like a tedious thing. So let's break open a new folder here, and we're going to copy day 6 problem 01 to 7, so we can keep our parsing stuff that we already have for just getting like lines, right? We have this. This is a memoized function that will grab all the lines of input.txt. It'll read it all into lines, and then it'll take off the end. And if we call it a whole bunch of times, it doesn't matter. It's memoized. We're chill. Also, we should get our puzzle input. So let me grab that and put that into our project as well. I'm going to replace our old input on our desktop, and I'm going to drag this over here. I wonder if these can have more than one comma on a line, though. That's kind of like my big question. Okay, they definitely can. But it follows the pattern of... There's no like and or anything going on here. Because this line right here, lavender bags contain 3 plaid white bags, 5 pale salmon bags, 4 dull salmon bags. So we're actually probably gonna split on that, right? Okay, so we're just gonna have some tedious parsing here. To start off, nothing too hype. So let's get into our problem 1 here. So we'll start off by writing a little parse line thing. And also, while we're at it, let's put sample. We're going to generate this as well. Okay. So we'll be working off of our input sample initially, but we're going to turn each line into a structure of some sort. If we cared more, it would probably be like some sort of hash table, but we're some sort of actual class, but we're just going to do a hash table here. So the format that we know is adjective, color, kind of specking out what this is, right? So anytime we see the literal bag descriptor, that's going to mean word color bags. And we're just using quotes to kind of like indicate this is like a literal thing. Word and color a bit. Like if we were actually writing out a formal grammar for this, it would be like a little more complicated, but we don't really care, right? Bag with quantity equals and also we'll specify. Okay, so int. Call this word color. This will be a little simpler. We're gonna. Our variables are gonna be caps. And this can be the bags is optional. It could be bag or it could be bags. Okay, so I'm just kind of spelling this out in kind of like a pseudocode way to just kind of get my head around what this can possibly look like. Line equals bag descriptor. Is it ever an? Oh, okay. So wait, no. The A is not. The A is never a thing. Okay. Let's actually make this a little shorter. Let's just call this bag. Bag. Okay, so this is where we fork a little bit. It's not gonna be like really precise. We're just gonna be. Well, it's gonna be bag quantity or. Say bag quantity 0. That's kind of like regex syntax. 0 or more bag quantities. Another option is it could be no other bags. And we can actually take out the periods, make it part of this. Okay, I think we have kind of like a quasi BFG kind of a. BFG, is that the right word for it? I don't know. I haven't looked up language syntaxes in a while. But we have a basic syntax of what we're looking for here. So we know that the word contain is only going to happen at most one time, right? It's going to happen exactly one time. So let's do first. Take line, we're going to split it on the contain. What we're going to end up with is we're going to have the container and we're going to have the rest. So let's let me actually look up something real quick because these are always going to have periods. So let me look up the documentation for chomp real quick. I know that in Perl there's a way that you can do it only for new lines, but we want to just chop off like whatever's at the end because it's always going to be a period, and we never want that. That could actually be our first step. Chomp. Returns new string with the given record set. There might be just like an easier way to do this. Let's do low 0 to -1. I think that gives the whole thing. Yep, that gives the whole thing. That will give us that will put us in hell though. Okay, there we go. So line equals line to -2. So we never want the period, so we'll just take that off initially. At this point, we are making a copy, which is nice, so that means we don't need to worry about any side effects of mutating this, which I would want to do anyway, because I don't like mutations, I don't like side effects. Okay, so if our example is, take like one of these examples, take a complicated example. That was not what we wanted to do. No, that was way too much. There. We have a little more to work with. Okay, so that's our example. The container light bags rest equal white bag to muted yellow bags. We can actually also, before we do anything, we can g-sub out the word bag. And do I want to do like a leading space on that also? Maybe. I'm wondering if like there might be like a color that like kind of looks like bag also. I'm kind of worried about that. Oh, did I ruin my input? No, I don't think let's just run with this, I think. The S is optional. If we got it though, we take it out 100%. So we're gonna be left with a string that looks like we are going to end up with this for our stuff now. Light red Contain 1 bright white, 2 muted yellow. Okay, so this is already getting much simpler. We don't need any of that extra stuff, so we're actually really good here. And so this changes here to, you got this here. I'm trying to think if like we're ever going to end up in a place where we accidentally have double spaces. We might, because, well, we're splitting on contained space, right? So that bag will never have a tailing. Okay, I think we're actually good with trailing spaces. I don't think we're ever going to run into that. That's not a real problem that we have. Let's look at what's next. So we already have 1 bright white. We have 2 muted yellow. Pretty soon we start needing to think about what structure we want to turn this into. I guess initially I was thinking that we actually need to separate out light and red, but we don't. That's actually a single identifier, right? So we don't actually need that. That's like kind of like one single thing. So I was thinking at first, oh, well, like maybe we need to split on space and make that happen. But I don't think we do. I think we're actually okay there. Okay. I'm just kind of like thinking through everything that we're doing. We don't need to do anything more for container. Until we're ready to throw that into a structure, we're actually good to go there. We need to do more processing on rest, though. So rest is now, we can have a variable number of these, right? So let's first we're gonna just make a little array contained. We might change the numbers, the names around once we have an idea of what we're gonna do with this structure. And let's do if rest doesn't equal. Let's actually make this into a new method. Parse rest so that we can not nest our logic so deeply, right? Because we're gonna have an exit clause here. Because sometimes there's no other bags. Is it going to be no other or no other space? Because we took out the space before bags, so we're actually okay. Actually, let me also double check something else here. Bag, G sub. And actually, let me make this. Okay, that does it. I was pretty sure that G sub would globally, because I think the G is for global search and replace, and it turns out it is. So we're good there. So yeah, so I like if we have like kind of like a nesting logic. It's good at that point, I think, to break out into a new method or a subroutine or something, so we can just kind of like encapsulate. We don't. Whenever you have like really deeply nested logic, that just gets kind of like hard to read at that point. So we don't need that. So what are we doing with this? What we're doing is, okay, so we're taking rest. We're gonna split on comma. If there is no comma, then it's just gonna be a single array, a single element array with the entire string, which is what we want in that scenario. So like, for example, if we have 1 bright white, comma, 2 muted yellow, we would end up with 1 bright white as element 1, 2 muted yellow as element 2. But if it was just 1 bright white, it would just be 1 bright white as a single element array. What are we calling this? called it kind of like bag quantity. It's not a great name, but it's the name we came with, right? So I believe that split takes another argument that limits the number of times it splits. So let's do bag, 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 split, space, and then 1. Okay, so that gives us... Perfect, that's exactly what we're looking for. So suppose that this was 1 bag, bag. This would give us 1 as the first element, and then bag, bag as the second, which is kind of like what we want in the case of like 1 bright white. Cool, that's it. So that's 100% what we want here. That's awesome. Quantity bag. Split on space, but we're only going to do it for 2. So I think we... What do we want to have parse rest to return? I think we probably want to have it return an array, maybe? Maybe a hash. Yeah, I think probably a hash is what we're going with here. So let's make a new hash. Oh, so this should be a hash too. Yeah. I think we're probably going to want to be able to look this up by the bag color and everything. So we don't strictly need a formal return. We can just do red, and we're just going to do that way. So now we can do contain bags equal parse rest. So I guess we can kind of run with the whole hash structure here, I suppose. Yeah, I think we can stick with the hash structure going all the way up. So the hash structure we're going to return is going to like return want that to okay. The formatting's really weird here. We'll keep with our notation from before. Bag as keys. It's not persisting my I think this is clear enough, right? So this bag can contain many bags that all have quantities. Okay. So let's set up our structure here. We are going to we're just gonna call this red for now, because I don't really have like a name for this yet. Naming is one of the hardest things in the world, so actually this might let's actually just return like a 2-element array. That might be easier to work. Color. Get rid of all this here. It's kind of weird because I'm kind of like defining data structures before I know exactly how I'm going to use them. Because I'm not entirely sure how I want to do this search yet. So we're actually kind of like done already, right? Container. And we have our structure here. So let's go back up to our main, and let's take just like an example. Let's take an example and see what this looks like. So that's a reasonable example, right? So let's do parse line or be pretty print that, and let's make sure we didn't syntax error, and let's make sure we're making a reasonable structure out of this. Problem 01. Undefined method split for enumerator. So we're calling split on an array at some point when we don't. Okay, doing so 29. Where is that? Why would the line be an enumerable? That's let's just see something real quick. Hello. Okay, so we're still strings here. Oh, I wonder if it's because I didn't put the second thing, because if you don't put what you're replacing, it expects a block that will specify what you're replacing with. I forgot that was a thing. Yeah, okay, that totally makes sense. Okay, so light red contains bright white and muted yellow. This all makes sense. If I want to carry at least one other bag, how many different bag colors would be valid for the outermost bag? So basically, I want let's start off. What we'll do is we'll just turn this into a bigger structure. Throw that out, and we will use our input lines. Input lines, map, line, parse line, line. And let's pretty print that and see what this whole jalopy of a structure looks like. And enumerator. I think that's happening because I think that the PP, that the function call collects this, and the 2A kind of gets tapped onto the very end of it. It's very odd. So let's that. And we should get a whole bunch of output now. Okay, so we kind of turned this into a structure. I don't know if it's a good structure yet, but it's a structure. I think we can all agree that this is a structure. So what we can do is we can first of all, anything that's like in this top level is automatically good. And like if we ever find muted yellow, we're automatically good. And then anywhere we see muted yellow down here, you see who the caller is. And we add that on as well. And anything that has that caller also. So like I would look for muted yellow up here. I look for muted yellow down here. And then I would look for light red. So this is kind of like a... It sounds like recursion to me. Yeah, sounds like a recursion to me, but let's think how we want to structure this. Search. Needle. Needle. Ring. I feel like my structure might be like more complicated than it needs to be. Does the quantity even matter? The quantity doesn't even matter. I guess if we've already seen a specific needle, we don't want to repeat it, because that can just be an infinite thing. This could also 100% be a loop also. Could also have this as an int that just exits out when certain conditions hit. But I think it's a little nicer to do recursively here. In, out. I think this is correct. I think to make this a little easier, I actually do want this all to be in a hash. So I think what I actually want this to look bag bag quantity. Again, the quantity doesn't really matter here. We're going to just make a little hash here. Bag. Contents is a little more thematic, I think. I think that's better. So hash bag equals contents. Okay, I think this is a good structure now. I'm actually much happier with this structure. We don't need this to be map. Do each. We're not holding on to the result. And let's preprint the hash real quick. See what this looks like now. Okay, yeah, I think this feels better. And does this match what we expect in our faded blue has no other, dotted black has no other. Okay, this all, and I like this because the structure is like more consistent, I think. Okay, so let's think through. Actually be like, I think I'm already getting like a little too complicated here. So let's take a step back. Okay. So what we're going to do here for haystack, we're going to do a map. E. No, we're not going to do a map. We're going to do a more iterative approach here. Okay, so here's top level bags. So top level bags is going to represent bags that can possibly contain, that we're going to be holding that can contain a thing. Okay. So if haystack key needle top level bags make this actually break that up a little bit. If haystack keys maybe I like this actually a little bit different from, maybe I just want this to be an array. I mean, the keys is the same thing as having it as an array though. So what we actually want to do is we want to iterate over haystack each do bag hash. That's just kind of like it's not important what that's called. Actually, contents. Contents key keys include needle fellow search. Oh no, I've gone recursive already. So I'm gonna need an outer, else this is gonna go infinite. Yeah. So we're actually doing the exact same thing. I was like, oh no, we don't want to do that. With needle. Okay, so this is our exit out. If scene includes. God, I can't remember if it's include or includes. A B C. Include A. Okay, it's include. Okay, so if we've seen the needle, bail out. It's done, Zo. Everything is ruined. Actually, it's not ruined. It's perfectly normal. So I'm gonna need to mutate needle. I'm gonna need to mutate scene, but I don't want it actually to mutate on the outside. Because arrays are usually passed around by reference. So anything you do them messes with all other copies of it. Anywhere on the stack that has that scene. So I want to be generating new arrays each time for scene. The end of this is definitely gonna be. Also, let me just double check. A, B, C plus D, E, F. Okay, so that flattens something. So shallow search could have just been search, is what we're realizing here. So we go through each element in the hash. We're returning if we've already seen this needle. So if I just like do a scene and add on the current needle, this will never proc because it'll always be. One way I could do this is scene plus needle, but that's not going to work. How's this normally? I haven't done recursion in such a long time. I'm kind of like forgetting the pattern. Scene include needle. We definitely need that memo to make sure we don't repeat ourselves. Another interesting way, I guess we could also memoize this in a way. That might actually be a kind of cool way to do that. I've never done that, I don't think, with. Let's see if that actually works. We're just kind of like experimenting here. actually a little dirty because it's using shared state in a sense. Um, in. Oh, but that doesn't really work because we need to return scene. Let me think here. Let me look up something quick. Recursion with memo. I wonder what happens if we just assume there's no loops and go like infinite. Maybe it's in the haystack we actually need to not do this. We could also do this iteratively. We actually could do this. I feel like I'm just kind of like spinning my wheels because I haven't had to really think about algorithms in a very long time. Kind of like a weird thing to say. These sort of exercises are not something that come up at work all that often. Here. Kind of fun though. It's kind of fun to stretch your brain into. You haven't in a while. Needle haystack. Let's see what happens when we just don't have the scene. I think we do need it, but let's just prove to ourselves that we need it. Let's actually just see what happens if we just run this. I don't think it's going to be correct. See if this runs for one. It does run. Search. What are we looking for? Shiny eagle. With this stuff. Okay, so that's definitely more than 4. So we've done poorly here. Let's add some prints. Because I thought it was just going infinitely. But let's do unique here. Change it. We're off by 1 for sure. So that's really interesting. Okay, I thought that algorithm was be mostly correct, but it's not. Let's I think it's kind of fun about recursive things. You can add print statements to kind of see the process of it. each time we do. Baghead needle top level. Let's see how this works. We'll initially print out structure. How wrong it's going. Okay. Shiny gold did exist, so that makes sense. Bright white had shiny gold. Bad. Oh, we didn't actually add. Contents keys include goal. That should be a little more correct. Although still, like, terribly wrong, because, I mean, we already had too many. Okay, so, first we look and say, hey, the thing we're in had shiny gold. Bag bright white had shiny gold. Which is true. Bright white had shiny gold. Haystack had bright white, so bright white's added on. Bag light red had bright white. Okay, that makes sense. Search red. Haystack had light red. We had light red. Let's actually. I don't think we actually needed this part here. Actually, I think this part was actually wrong because we're already adding it in the recursion. Shiny gold. Haystack had shiny gold. Big bright bright white had shiny gold. Okay, so we had bright white on. Light red had bright white. That makes sense. Dark orange had bright white. Muted yellow. Good. Yellow search. Oh, I think I see what I'm doing wrong here. I'm kind of assuming that. I think I'm doing it backwards. I'm assuming that, like, if any inner bag can contain it, the top level can contain it. Yeah, I think I'm backwards here. So how does this algorithm actually look? Think about it. If bag can contain needle directly, bag is good. Um, Bags that can contain bag are good. But I don't think I'm doing that, right? Saying, okay. The first part I'm doing. Ah, this is twisting my brain a little bit. So, oh, mine was all actually almost it was off by one. It was 5, and I was including muted gold. So maybe this was correct. I don't know. Maybe this actually was correct. I don't know. Let's just yellow a little bit. So we expected bright white to be there. Expect light red to be there. Expect dark orange to be there. We expect muted yellow to be there. We expect light red to be there. So the only issue, and also we need to do uniqueness here. Shiny gold. Because the question was, how many bags can contain shiny gold, and shiny gold cannot contain shiny gold. That. Oh, we did. Did that wrong. We just wanted an array with just shiny gold. There we go. So I think this is probably gonna not work here. But I'm okay doing a timeout, and maybe it does work, and just do. Wait, did we actually get 4 before? Yeah, we did get 4, so. You ruined everything. There, that was different. I didn't undo, and I kind of forgot the them key binding for undo the undo. We're just gonna switch over to our main file and just rip it and rip it. And this is risky, I'm not going to lie. But I don't think we've actually really solved this, so it's kind of okay to just kind of like yellow out an answer. We got the right answer, okay? So we actually did have the correct algorithm. I was told that like first part and second part don't really have that much to do together, so the fact that our first part was kind of scuff is kind of fine, actually. So what we're going to do is we're going to get rid of stuff we don't need, and we're going to make a copy of our file, because we always say that we're going to do that, and sometimes we screw up, and then I'm sad after the stream because I have to clean it up manually. So we get rid of search because we do not need that. Our parse line's fine. Our shallow search is fine. Okay, we're a-okay here. So we're going to be good to put this up on GitHub. Problem. Problem mode. Okay, let's go. It's getting pretty expensive to fly these days, not because of ticket prices, but because of the ridiculous number of bags you need to buy. Consider again your shiny gold bag and the rules from the above example. Faded blue contains 0 other bags, dotted black contains 0 other bags, vibrant plum contains 11 other bags, 5 faded blue bags, 6 okay, so we have rules. So a single shiny gold bag must contain 1 dark olive bag and the 7 bags within it, plus 2 vibrant plum bags and the 11 bags within each of those. That's a lot of bags. Of course, the actual rules have a small chance of going several levels deeper than this. Be sure to count all of the bags, even if the nesting becomes topologically impractical. For example, a single shiny gold bag must contain 126 other bags. Yikes. Is this the same example from before? No, it's not. How many individual bags are required inside your single shiny gold bag? Okay, so let's make a second sample rules here. And this is just going to be our test case. Test again. A shiny gold bag must contain 126 other bags. Okay, so we're starting from a fixed start point, and then we're just kind of like going down and seeing like how many things we need underneath it, right? I think this one's actually a little more straightforward. So we already have our structure. We have our structure of input lines. Turning it into a hash. Not nested bags. So we'll just include our input. I guess we still have a needle here. So we're going to be returning a number from that. One, because we're always counting the bag we're looking for, right? I'm kind of concerned about off by one here. Thinking about this for a second. I think we always want to start off with a sum of 1, and then we're going to return sum plus bags inside. And then the end result's probably going to be like 1 minus that. So we know from our bag topology not nested. There's going to be like a number of times this has to happen too, because there's a quantity here. So bag topology equals each, rather. Bag contents. I feel like I'm starting to lose my steam, so we'll try to get through this pretty quick. So for the contents of the bag, inner bag, and it's a quantity. Well, let me just be paranoid here and make sure. I know that there's an each pair, I think, also, but maybe I'm thinking of Perl. I always get so A, B, each KV, puts K, puts V. Okay, so that works away. Okay, so it does, each returns a 2-element array, and we break it up with this. So we're not looking at the entire bag topology, though. We're only looking at needle. Because we only care about what's has to be inside the current bag. Okay, so let's do bag, quantity, sum plus equals. So I think this just works here. This is just simple recursions. Count bags. Now we're looking for bag. We need to actually do, no, I don't know why I thought I had to do this way. We need to do this actually a certain number of times. Quantity times do this. Now this, we could make this a lot more efficient by memoizing, but I don't care about doing that at all. So, for example, like our gold bag might need like 5 white bags inside of it. So that's why we're gonna run the white bag command like 5 times. Okay, I feel really good about this. Yeah, this should 100% work. And we just return sum here. So we're adding up the sum as we go along. We're counting the bag itself. And I think that what we're going to end up here, because we're running this against... Oh, that's... Okay, we don't need a shallow search. That can go away. And let's do input sample 2. If we print out the sum from here, I think it's going to be +1. So I think we're going to end up with 127. If this all works the way I think it does. Shiny gold. Okay, let's see what this does. Problem dose. Okay, we screwed up here. Oh, these are strings still. Okay, of course, we never actually cast these into strings. So we can actually do that over here. In our parsing. Yeah, because these are always supposed to be strings. These are always supposed to be integers. 127. What did I say? We were 1 off. That is exactly what we wanted to do. Okay, so this is so easy right now. So easy. So what we do is we just take off and we run it against our real input, and we're going to subtract 1 from it. And actually, let's be a little more proactive. Let's say that for the people coming after us. Let's say sample 2. Let's run this. Okay. And now let's just run it against the input and see what happens. Wow, that's a lot of bags. I would not want to go to that airport. No, sirree, that's a lot of bags. So now is the moment of truth. Do we find shame in a timeout? And if there is, I'm not really sure what the next steps are, so just saying, better not be a timeout. Or do we find victory in yet another star, building up stars as if we were in kindergarten and we knew our ABCs and we knew how to tie our shoes and we put things into the cubbies and shared appropriately? I think we just gotta do it. We gotta do it. We gotta hit submit and see what our destiny is going to be. That is right. You are 1 gold star closer to saving your vacation. We have completed day 7. I can share the victory, or return to my advent calendar. Well, I don't need to share my victory because I shared it with all of you. And by all of you, I mean just me, because no one actually bothered to show up for this. No one showed up for this chat, and that's totally fine. That's totally fine. Just saying it in front of the camera makes this a motivation in and of itself. So it still has value for me, and this lives in perpetuity on YouTube. So you can check this out later and be like, "Yo, this is what happened. These are the events that transpired, and we're okay with that." So that first part took way too long. Way too long. It was actually probably a lot easier than I should have made that out to be, but that's fine. We got through it. We were successful. And now, it's over. Our time is fleeting. We only spend so much time together, and then it's time to pack up, hit the road, until tomorrow. That's what's going to happen. We come back tomorrow stronger than ever. Thank you so much for engaging in this journey with me, and I'll see you tomorrow. Make sure to follow the Twitter, drop a follow on the channel, check out the YouTube, do all the things. Join the Discord. You'll get a notification when the next time we pop on live. Hope you all have a great evening. Cold, wintry day. Bye.